Hi, today we will talk about slices, maps, and how we can iterate through slices and maps. What is slice? Slice is a list of ordered elements. Let's see how we can define a slice and provide some elements in advance. For example, if I say grades, and this opening closing bracket will mean this is a slice, an ordered list of elements. I can provide the type. This can be any type. It could be string, integer, or it could be any, which means any type. Let's try with int, and we need to use an opening and closing curly brackets that we can provide values 1, 2, 3, 4, 5. Let's print this out. fmt print line and grades. Run the code, go run dot, and I have the numbers. Let's see how can I pick one of these elements. If I say grade 0, let's see what's happening. It prints out 1 because this is the first element and the list of the elements are indexed with 0, starting from 0 based elements. So this is element 0, element 1, element 2, element 3, and element 4. So if I say element 4, I expect this to be 5. That's correct. Let's see what happens if I would say element 6. This is a not existing element. My code will run into an error. There's a different another way how can I add values to my grades. I will make it empty. I'll put it back to just simple grades. If I run this, it's an empty array, empty slice. There's a keyword called append. If I say grades equals grades, append grades, 1, and run again, there's one element 1. I can repeat that as many times as I want to. 1, 2, 3, 4, and 5, and that works. Okay, let's try to define the grades with the var keyword. As we learned, we can do that as well. In this case, I don't need these open and curly brackets, and I don't need the equal sign as well. If I run again, that's 1, 2, 3, 4, 5. It looks like it was identical, but it was not. The very big difference between defining with the var keyword, that in this case our slice will be nil by default, but fortunately the append keyword will take a look at the variable, and if it's null, it will allocate a memory and will start populating the data. So both works fine using the append keyword. But there is a third and probably the most important way. How can I define this slice? I can see grades, go back to the previous way, column equal, and say make and provide a value here. Let's run again. I will clear the console so we can see it clearer. Go run, and it still works. I will explain what it is, but first let me put a number here. Go run, and I have 5 zeros, 1, 2, 3, 4, 5. What happened? This parameter called length. If I provide this parameter, then the computer will set the length of the grade slice to 5, and by default these 5 elements will contain the default values of the integer, which is 0. In this case, I could provide the values 1, 2, 3, 4, 5, 6, whatever, the following way. And it works again if I correctly use the indexes. And that works again. Okay, let's see what happens if I change it back to 0 and provide a 5 here. Comment this out, come back and comment this back and run again. And I don't have 5 zeros, 1, 2, 3, 4, 5, but now I have 1, 2, 3, 4, 5. What happened? This parameter was the length and this is the capacity. So if I provide the second parameter, my Golang will allocate the memory for the 5 elements in advance, but we'll set the size to 0, so the append still works. Why is it important? Because allocating memory is a heavy operation. It's usually a call to the operating system, and if I know the numbers ahead, or the approximate numbers ahead, I can use both ways. I provide the first parameter and I use this way to populate the values, or I provide the first parameter as 0, provide the capacity, then add the values with the append because the length is 0. Let's prove this. fmt printf, this is formatted text, length, and this min digit, and capacity, and this min digit again, and provide grades twice. No, len grades and cap, which means capacity grades. Print the result, clear the console, and length is 5, capacity is 5. Let's add /n for new line so we can see it even clearer. So length 5, capacity 5. If I remove these appends, a couple of them, then the length will be only 2, but the capacity still will be fine. Let's go with the previous version with the indexes. Remove this one for now. Change it to length because we know it only works with length. Let's verify if it still works. It still works. Let's try how we can iterate through the elements. We can do it with the for keyword. If I say for I, then v, I stands for index, v for value, semicolon equal, range. Range is a specific keyword, which means that if something is iterable, we can step through one by one. That's what iterable means. Then it will step through one by one. It will return I as an index, the element index, and v as the value. And print this out. And of course grades. And print this out. fmt printf index percentages d is means digit alias number, and value, it's also a digit, that's the value, I and v. Remove this for now. If I run the code again, it's even better if I add a /n. This is stands for new line. Then it will display index 0, 1, 2, 3, 4, 5, I mean 4, and value 1, 2, 3, 4, 5. That's what we're expecting. Okay, let's say something else. And for example, I would like to know not just 0, 1, 2, 3, 4, 5, but how what grade different students have. Students have names. In this case, I can use something called maps. This means that a map have an index of string and the value of integer. If I do this, it's not a slice anymore, it's a map, which means these indexes are not automatically generated numbers anymore, but predefined strings. I can say Joe, John, Frank, Doe, N. And if I want to run again, I have to change it to S, because now the key is a string. I can use the same iteration. If I run this again, Joe have like a grade 1. I change it to grade so it's even more clear. So Doe have a grade 4, N have a grade 5, Joe have a grade 1, and so on. If I run it again and again and again, probably we have seen that sometimes the order is changing. Now it starts with Doe and Joe, Joe, John, Franks. That's very important that if we use maps, then in this case the map will not guarantee the order what I provide. So those are not orders. It can come back in any random order. It's very important because we can create a lot of bugs if we are not aware of this. And I defined the capacity as 5. That was a good practice, but in this case I can do it without capacity, and then automatically will increase the capacity of my map. I also could do this. Without the make. So we go back to the previous versions and it still will work. And let's see what happens if I say var. In case of var, I don't need these curly brackets. And oops, I have an error. This is very important because var defines the grades, but the grade will not be created. It will be a nil pointer and everything will just fail. It worked with our append keyword, but it's not working here because we're directly trying to use the variable which is just defined as a type, but it has a nil value. So that's a very significant difference between these two variations, because in this case I have an empty map, and the previous case I have a nil variable with the type of the map. So that's about maps and slices. Let's see a little bit of these iterators or loops. If you use other languages, you know that other languages can have do loops, while loops, for loops. In Golang, for simplicity, we don't have these variations. Everything is for. The range we already know now. This is the iterator. We can just say for fmt print line I. Let's define I and give a starting value of 0 and run it, and it will just display 0 forever. This is a forever loop. Let's increase I, and it's just going to go forever. The while and do loops in other languages are like testing in the beginning for a condition or testing in the end of the condition. If it's testing at the beginning of the condition, then it means that it will execute the body of the loop at least 0 times or more. If it's testing at the end, it will execute the body of the loop at least once or any other times or forever. Let's see how we can solve it in Golang. If I say if I larger than 10, then break, I can just stop executing. Let's run it. and I have the numbers from 0 to 10. If I move it to the beginning and run, then I have another loop which breaks at the beginning. But this one can be simplified. If I get this condition and remove it and add it after the for and reverse the condition, because it tries to execute this conditional statement, and if it's true, it will iterate. If it's false, it will stop executing our for loop. And if I say go run, it works again. And of course, there's the traditional way as well, when I can replace this with the same syntax as other languages have, saying I colon equals 0, semicolon I smaller than 10, semicolon I plus plus, which is 3 blocks, initializing the I condition until it runs, and the modification of I. Let's run it, and it works. And thank you for listening to this episode. In the next one, we will go to a more interesting subject. We already learned about structs, how we grouping like properties together. We already learned functions, and we will combine functions and structs together. And we will create something like an object. Golang is not an object-oriented language, but we can do something which is similar to an object, and this is what we're going to learn in the next episode. So don't forget to subscribe to the channel, click the bell icon, and I will see you in the next one. Goodbye.